Welcome back to part 4. I think this part will probably be the single most difficult part that we are going to work on together. So what we're going to do in this part is we are actually going to create our tokens class. And this class for us is going to represent a set of tokens parsed from a line of code. And so actually inside of this class will actually be our whole parser function. That way we don't have to write a separate parser function, and we kind of do the work of parsing each line into tokens as we read in each individual line. So we don't really have to think about it. We just say, create me a new tokens object, and we just know that that tokens object is going to have the tokens that we want to work with. So like we mentioned before, if we just quickly, once again, look at our assembly file, the maximum number of interesting tokens that we can have would be 4. So we can have a label, we can have an instruction, and then we can have 2 arguments. We're not going to make comments into a token. There's really nothing that we can do with comments when we write out that executable file. We're not going to put any like debugging information or anything in to our executable files. So 4 is really the magic number for us. So because what we're working with is strings and we're really just kind of parsing out substrings, the actual things we're going to be storing themselves will be strings. We'll have a label string, we'll have an instruction string, we'll have, I'll call them first and second for first and second argument strings. The next thing we're going to need is an array of all valid Intel 8080 instructions. And I happen to Google Intel 8080 instruction set, and I got back this very handy page at pastrazor.com, which has a table of all of the valid instructions. And so I cheated because it would take quite a long time to write them all out. I went and copied them, and so here's all of our instructions. And all I did to get this array, and I made this just an array of strings called instructions, is just look at this table here, and just every time I saw a new and unique instruction, I just added it kind of in order. So this is not alphabetized, this is actually in the order that they are shown here in this table. And it looks like I copied it in a way that over-preserved some spaces, so I'll just go ahead and remove those over-preserved spaces. Okay, so what do we need to do next? So we have our 4 tokens. The only really thing left to do is write that parser function. So we're going to say the constructor parses a line into, we'll say up to 4 tokens, right? Because there could be fewer than 4 tokens, but there definitely won't be more. So again, that's that this method, right? Which will run whenever we create a new tokens object. And like we said, that's going to take 1 argument, and that argument's going to be a line, and we can see that kind of right here. Okay, so what is it that we need to actually do? So we need to do a couple things. So we need to kind of read through the different lines. So the first thing we're going to do is say, do we have an empty line? So if we have an empty line, then we have absolutely nothing to parse. We can say, if this is an empty line, we're done. Easiest line we're ever going to have to parse, a totally empty line. So we can say if line, and just like our strings array had a length property, strings themselves in D also have a length property. You might be used to something like strlen in C and C++. It's actually a property of strings in D, which is super nice. So we can just say, if for some reason our line length is 0, we're just going to go ahead and return. We're done. We don't have to worry about anything. Next thing that we need to do is we need to know when our tokens begin and when our tokens end. So let's do that. I'm going to start with when tokens end, because that one's a little bit shorter. And all we really need to know about whether or not they end is Whether or not true, it's ended, or false, it is not ended. So we can say, is this the end of a token? And so we'll have a Boolean, we'll call it end of token. I'm a very original function name creator. So what is the end of a token? Well, I guess it makes sense to say, what is a token? So for us, a token is going to be alphanumeric characters, numbers, maybe some punctuation, but essentially just ASCII characters. So the end of a token would be, in my mind, a space, a tab, right, our white space, a null, right, and that's how we're going to know that we're at the end of a line for sure. We'll see that null byte. But there is one other character, and that's that semicolon character, right? Because if we have a semicolon, then we must be in a comment, because a semicolon, as we saw, is our comment character. So I'm going to say, if the place we're looking at now, and I guess we're going to need some sort of variable to remind us of where we happen to be. So why don't, in this, we will say size ti, just so we remember. And I guess I'll also bring this end of token thing. I'll actually bring it into the constructor function, just so kind of logically these things all stay together. And I guess I'll reflow my comment here. Okay, so is this the end of a token? Other nice thing about D is you don't have to manually say that a variable equals 0. You can just declare it and it automatically gets initialized to 0. All right, so if the character in the line we're currently looking at is white space, which is a space, or a tab, or the character we're currently looking at is a semicolon, because then that starts a comment, or it is a null byte, which we are using as our end of line character. If it's any of those things, then it can't be part of our token, so our token must in fact be complete. So in that case, we can return true. In any other case, we should return false. Easy. But how about if what we end up having to worry about is what is the beginning of the next token? So we can do something very similar. We can say, get to the start of the next token. And so again, this can be a Boolean. We just want to know true, false. Are we at the next token? There are two things we need to check to know whether or not we have any more tokens on this line. First thing we need to know is, are we at the end of the line? Because if we're at the end of the line, then there's simply no way that there can be any more tokens. We're at the end of the line. The other thing is we can also do an end of token check. Because end of token check includes that null byte, and because there's no rule that says you can't have white space or a comment or white space or a null byte at the end of the line, we should check all of those things. So while we have not reached the end of the line and we currently have either a white space character or something like that, we should be able to say, keep moving forward, right? Because our white space characters will be what separates our tokens. We also want to detect if we've hit the end of the line. So if it's the case that we have not reached the end of the line and we're currently pointed at some sort of white space or some sort of end of token character, we can say, move to the next character. But there's actually something we need to do before that. We need to say, if what we've seen is a comment character, then we can just say return false. Because it's true that if we see a return character, the whole rest of the line will have no more valid tokens. It'll just be a comment. So that kind of takes care of that. We can also say, if I is equal to line length, or we saw that terminating null byte, we should also return false, because we'll also be at the end of the line and therefore there are no more tokens to go to. In any other case, we want to return true. In any other case, it'll be the case that we're at the beginning of another token. So that's really it for this episode. And then we'll go through parsing in the next episode. Special case for if we have an empty line, we're just done. We need to know what the end of our tokens are, because we need that information to know when we've hit the beginning of the next token or we've hit the end of the line. So let's save it. Let's commit it. We'll say next and end of token functions, beginning of parser. And with that, I will see you back here for the next episode.